In recent decades, there has been substantial advances in time series modeling as well as their performance on benchmarks across various individual tasks such as forecasting, anomaly detection, classification, imputation. However, in real world, as a financial manager or electricity grid manager, simple predefined tasks may be unsatisfactory. For example, after forecasting future prices, you might want to know how to optimize your investment portfolio. You often need to ask more sophisticated questions involving time series. In this video, we demonstrate such real-world use cases of TS Reasoner, a truly transformative agent that handles multi-step time series reasoning. With TS Reasoner, it enables efficient and integrated workflow of scientific and engineering workflow where traditional workflows are usually fragmented and require time-consuming process of coordinating between domain experts. Scientists and engineers need a cohesive, automated approach to solve complex questions, allowing them to focus on what they want to achieve rather than how to get there. With any given question, TS Reasoner is able to generate rationale and execute the corresponding tools in a step-by-step manner. With the integrated evaluation framework, we are able to evaluate different types of questions and demonstrate the final answer obtained by TS Reasoner, as well as the evaluation result. Now, suppose you are a finance manager and need to optimize an investment portfolio. You may want to ask a question like this. Choose the stocks you want to invest in and let the TS Reasoner do the investing for you. Now I have historical stock value data for stock GDOC and WEN. I'm interested in investing in these stocks with a budget of $2,000. I want to make at least 0.1% profit. Please give me an investment strategy for the next 10 days. The rationale shows Reasoner will first forecast the future prices of the stocks, then generate the objective function and constraint function for the questions. Finally, the Reasoner will optimize the investment portfolio based on the generated functions. Reasoner can predict future stock data and provide invest strategies based on a given budget, stop-loss point, and historical stock data. The second question type comes to predict the stock price in the future. You are free to change any stocks type you want and any type, like volatility, trend to predict. Now the prompt is to predict future trend given information about two stocks. The rationale shows the Reasoner will forecast the future stock price based on time series foundation models such as Tempo, Time LLM. You can see final results shows the forecast values and trend for the target stocks generated by the TS Reasoner. Another prediction goal is volatility, which is an important factor to analyze the market. The rationale prompt 2 stages. First, forecast the future price, then predict the volatility. The execution results contains the forecast and volatility values. For other time series data, such as energy data, we can also have the Reasoner understand and give programs to predict potential future data. Imagine you are managing an electricity grid load power. You may want to know the electricity demand for the next few hours. But it may be insufficient to just make a forecast because a simple forecasting step may yield result contradictory to system regulation, such as maximum allowable system load. You could ask TS Reasoner to solve such problems like forecast the wind power for next 20 minutes. Here we pick the ZES-PP Zone 17 dataset to try out. The rationale prompt 3 stages. First, the Reasoner will forecast the target variables based on the historical data. Then, the refinement function will be generated to control the input constraint and requirements. Finally, the Reasoner will refine the values based on the function and historical data. Here comes the results. The multi-step reasoning is really amazing. After the refinement step, the execution results meets the requirement and MAPE are really small. As a scientist or analyst, after getting some data, you may need to understand the causal relationship between variables. That's why we need to come up with a new scheme to predict the connection between some masked data. We additionally propose a causal relation-based datasets generation method and try to let the reasoner predict the initial causal relation based on the generated data. The rationale prompt shows that the reasoner will first calculate the Granger causal matrix and then extract the causal relation based on this matrix. The final results shows for data 4, the accuracy of results which is generated by reasoner is 77%, which shows a great ability to reason causally with unknown time series data. This is our latest proposed time series reasoner, which is a program-based reasoner agent, and we expect that such a reasoner can better bridge the gap between LLM agent and time series domain.